now. Okay, so happy Thursday. We are recording this here on Thursday, May 21st, right on. What we are doing today is we're going to basically wrap up our unit module on quadratics. I'm going to go through a quick little section of notes that I created as a review topic. You might have noticed it in the most recent post in the Google Classroom. We'll start off with that after our announcements, but I don't want to get too far ahead of myself. Let's go over the announcements first. So our classes finish off this week. They're finishing this week, so mandatory classes, anything next week is not necessarily mandatory, but optional. I'll talk more about that when we get down to number 4. Due to that, our Edpuzzles and assignments are basically all due by 5/22, which is Friday tomorrow. Notice that there is one thing that I mentioned that is not due on Friday. That is what we're going to talk about today, the lesson 25 homework. But other than that, everything else due 5/22. But again, that is all of our Edpuzzles and our assignments. The year-end form, please fill this out now if you haven't already done so. So that means by today, okay? You don't have to do it right this very second if you're here with us, but doing it ASAP would be great, okay? So please fill that out as soon as you can. And then also, our optional final project will be sent out based on those responses that I get today via email for those who have requested it. So real quick, this is what I'm talking about when I'm saying that form. It is this thing here. You can see that 51 of you and your classmates have filled it out, which is awesome. So we're looking at just over half of us right now. Hopefully we can get that number up by the end of today. Fill this out if you haven't already done so. It just lets me know what you're thinking and how you're feeling. And if you want the optional project, keep in mind that if you request the optional project, I'm going to calculate the grade. And if it's not going to make any real change to your score, like you're in a middle, like if you're at a middle C or a middle B, then it's probably not going to be something I'm going to send you. But the optional project will be sent out after my lunch today, after the session, and it'll be sent out through email to those who have requested it, okay? So on that note, today is our last Zoom class. So it's bittersweet. I know it's not quite how I wanted the school year to end. I was hoping to see each and every single one of you, but you know, we made do with what we had, and I'm pretty happy with the resiliency that y'all have shown. You've shown the ability to work hard, adjust, and adapt to the tough situations, and I'm really proud of what y'all handled it, not only as a testament to your strength, but also just resiliency through a very difficult year. So on that note, that's our announcements. The top dog way to solve quadratics, and it's going to be called, well, the quadratic formula. So we're going to legitimately learn a formula today to help making quadratics as easy as PEMDAS. And what I mean by that is PEMDAS is just rules that allow us to follow a specific order when solving equations. Now, quadratic formula has literally nothing to do with PEMDAS. But once we know the formula, it's basically step following like PEMDAS is. It's kind of a memorization tool. So we're going to do so by going over some of these problems first, and actually rather second, because first we're going to do the review that I created and posted to your Google Classroom to start. So without any further ado then, what I'm going to do is I'm going to clear this up. We're going to go to our review straight from the jump now that our announcements are done. So if you were just joining, by the way, y'all, no worries. We went over just our basic announcements. Everything due today other than lesson 25 homework. If you haven't already filled out the Google form, please be sure to do so. So on the most recent post on the Google Classroom, I posted what y'all are seeing here on the screen. It's just a quick quadratics review. You know, as quickly as possible as a nice review to what we've done basically over the last month or month and a half, okay? And over the time, we're talking about these things called quadratics. So let's just talk about some major defining features, and this is going to build off of this whole module and even our last unit when we were talking about pair functions. But quadratics have a degree, aka an exponent of 2. They're always written in descending order, which we'll talk about more when we get down to standing form. And its graph is called a parabola. And this is an upward opening parabola and a downward opening parabola. For those of you who remember, it's opening upward when your a value is 0, and it's opening downward when your a value is negative, less than 0. And what I mean by that a value is based off of what we call the standard form, and which we call it the standard form because it's the form or the way that it's written most often, standardly. So this is how they often look in equation form, and the standard form looks a little something like what you see here in red. Y equals ax squared plus bx plus c. We're keeping in mind, y'all, that the a and the c are really just numbers. We're using those variables a, b, and c to really just create an overall general look. It's just a generalization or a way of saying any quadratic, any power of 2 can be written in this form, but the a, b, and c specifically, when actually in an equation, like down here, are the numbers in front of your variables. So the a value in this example, y equals ax squared plus bx plus c, the a value is 1, the b value is 5, and the c value is 4. Okay. So again, this is just a review of quadratics on a macro, on a big level from where we've been, just so we can kind of see where we've been and then now apply it to the ultimate cheat sheet, as I called it on the post. So we've talked about some basic features of quadratics. We talked about the way that they're normally written, and how can we solve for quadratics, okay? So basically the entire goal, and I can't reiterate this enough, and I'm going to highlight it just to be sure, but the entire goal is that we're always solving for the x-intercept in a graphical way. We're using graph vocab to say where y is equal to 0. So anytime we're looking to solve an equation, a quadratic, anything with an exponent, we always want to set one side equal to 0. This allows you to zero property, which we've been working with a lot. Okay, I'm gonna bring this attention basically once we get into our lesson today. Just keep it in mind, y'all, this is just our straight up review right now. All right, almost done. Tactics for solving quadratic equations. 1, we can graph it. You know, you can always graph anything with a function table, an XY table, picking values of X, plugging them in Y. And when we do, what we're looking for when we're graphing is the x-intercepts, where Y is 0, where your height is 0, the values of X and everything equals 0. That isn't the way that we've spent most of our time this module talking about. Rather, most of the time we've been spent solving by factoring, okay? So when we factor, we always look for the GCF first, and then if we can't find that, we use the X table, which allowed us to expand and find GCF. So GCF is always part of the mix, but sometimes we can't do it right from the jump, from the beginning, so we use that X table tactic that we talked about in lessons 14 and 15. Throwing a lot of information right now. Hopefully most of this isn't brand new, it's just kind of a review. And that takes us to today's lesson. We can set the equation equal to 0. Consistency here. We do that whether we're factoring or whether we're using the quadratic formula. We find the value of x that makes everything equal to 0. We set the equation equal to 0, and then we solve using the quadratic formula, which is this behemoth right here. This huge, crazy looking fraction right here, notice the fraction bar that has a square root sign in it. This big formula right here is what we're learning about today. I don't care if you memorize it over our course of time in Algebra 2 Trig, whenever y'all get up there, or Algebra 2, we'll continue to see this. We'll work towards memorization then. But for now, I just want to introduce what the form looks like, so then that way we can use it to solve for quadratics. So the quadratic formula is x equals negative b, the positive or negative, plus or minus the square root of b squared minus 4ac, all of which is in the numerator over 2a. And the a, the b, and the c come straight from that standard form. Okay, so the a value here and there comes from the leading coefficient, the number in front of the x squared. The b value, highlighted in orange, comes from that middle term, and the c value comes from that last term. So that's what we're learning about today. And now what I'm going to have y'all do is turn our attention to page 684, where I've highlighted, now we're back in the book, little seamless transition there. I've highlighted the quadratic formula at the top of page 684. So we have the quadratic formula shown twice here on 684. And again, not caring about memorization, especially with the limited time that we have. Memorization isn't important to me, but application or using this formula is important, okay? So we always want to write our equation in standard form. We identify the a, the b, and the c, and we're going to do that first. So right off the bat, let's talk about this problem here on page 684, number 4, okay? Is my equation 2x squared equals x plus 3, is that in standard form? No, it's not. In standard form, you have all of the variables on one side. Or effectively, a nice way to think about it is in standard form, you always have one side of the equation equal to 0. So right from the get-go, you notice that that's not the case here. I definitely don't have one side of this equation equal to 0. So what I'm going to do is I'm going to change this equation here, and I'm going to set it equal to 0. And how can I set this problem equal to 0 here on page 684? Well, I am going to subtract x and subtract 3 from both sides. Subtract x and subtract 3. Now, it's kind of funky over here because I don't have any like terms, so I can't actually subtract them from one another. All that I could really do is rewrite this problem as 2x squared minus x minus 3, and now that whole thing is equal to 0. So what I've done here, y'all, is I have written this in standard form. The key thing I can't reiterate enough is you want to set the equation equal to 0 by moving all the other terms over to one side, and now we can identify what A would be in my CR. So in this case, my A, and let me kind of make this smaller, my A value is going to be the number in front, 2. Alphabet starts with A, quadratic equations start with A. My B value, oops, that's not what I was looking for. My B value, highlighted in green, is that number in front of a single x. So what's that number right in front of x? Negative 1. And last but not least, my C value, which I'll highlight orange, is the regular number, the constant, which is, as you can see, negative 3. Setting the equation equal to 0, we have A, B, and C, just like in the alphabet. First number, second number, last number. First number, second number, last number. And guess what, y'all? Now we can set up our quadratic formula. Negative B plus or minus, be useful if I use the same colors. Negative B plus minus B squared minus 4 times A times C, all of which is over 2A. Don't get intimidated or caught up in the memorization of this now. Use this in your notes. You can use your notes all day for this, okay? In this assignment, do the optional project. Well, guess what? On page 684, we're now on number 4, looking at C. Do I have the ability to rewrite this by using a little substitution? No doubt. What is my B value? Well, my B value, as you can see, is negative 1. So anywhere that I have a B in this formula, I'm going to replace it with a number I know B is. B is negative 1. So we got negative B plus or minus the square root of B squared, but keep in mind B is the same number still, negative 1, minus 4 times A times C. Well, what's my A value? As I zoom out a little bit, my A value is 2. So I'll plug in for this A up here, that number 2, and I'll plug it in down here for that A as well, which I'll get to in just one second. What comes after the A? Well, C does. So what comes right after this A? The value that we know C to be, and C is negative 3. So again, it's literally just a formula. It's just something that we can use to plug in the applicable information to make solving these problems super easy. All over 2 times. I need a reminder what A was again. A was, oh yeah, 2. So my 2 times A in my denominator will be 2 times 2. So real quick, let's pause it from here because after this, it's just purely calculator work, okay, or calculations. The very first thing that we did is we took our equation, realized it wasn't equal to 0, set it equal to 0. I moved everything on the right over to the left, so that way every number and variable was on the left side and the right side was equal to 0. Then I had my A, my B, and my C, just like the alphabet. First number, second number, third number, A, B, C. And then I plugged that A, that 2, in for wherever A was in the formula. I plugged my B value for wherever B was in the formula. And I plugged my C value, negative 3, in the one spot that C was in the formula. And now calculator time. Now we're here. All I'm going to do, y'all, is I'm actually going to copy and paste this just for sake of time. I'm going to copy and paste it right below, and I'm going to start working this thing down, okay? So notice we've already done all these things. Check, check, check. Now we got to simplify. Right on. Simplify is basically another word for solve right now. So let's start on the left. What's a negative negative 1? Well, negative negative 1 always makes that thing positive. So negative negative 1 is positive 1. All right, now I'm inside the square root, inside the radical. What is negative 1 squared? Because keep in mind, we got a PEMDAS operation right here inside the radical itself. So we're going to do negative 1 squared. And negative 1 times negative 1 is positive 1. All right, I'm going to stop there. I'm going to copy and paste this again. So all I did there was the b values, okay? Step by step. I'm going to zoom out so you can see where we've been. The big difference that I went is I did this portion and that portion right now in my simplification. That's how I got from there to there, okay? Now the next thing I'm going to do is I'm going to do this multiplication. What is negative 4 times 2? Negative 4 times 2 is boom, 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 negative 8. And what is negative 8 times negative 3? Well, negative 8 times negative 3 is positive 24. I'm going to remind myself that it's a positive with a plus sign. Boom, boom, boom. Okay, so really now to go from step 2 in the simplification process to step 3 is doing the pass. I'm doing the multiplication. I did all of this multiplication right out here. Negative 4 times 2 times negative 3 gave me a positive 4. All right. You bet you guessed it. Copy and paste it one more time. Showing all the work. Okay. As we get more comfortable with this, you know I always love you show your work, but as we get more comfortable with this, it becomes a little more efficient. See that. Well, next thing I'm going to do here, y'all, is I'm going to do 1 plus 24. What's 1 plus 24? 25. Okay. I'll even do one more step while I'm at it. What's 2 times 2? 4. Cool. So now we're down to basically the last thing we have to do here. And I'll zoom out and go over this as a review once we're done. But the very last thing I got to do here now is realize that, oh, this is saying x is equal to 1 plus the square root of 25 over 4, and x could also be equal to 1 minus the square root of 25 over 4. Now, why do I have two separate potential answers here? One, because it's a quadratic, it has a power of 2. We talked about that being our main rule. And 2, the reason why I have 2 full separate equations is because look at that little plus or minus sign. It's plus the square root of 25 and 1 minus the square root of 25. Cool. Anyone know what the square root of 25 is? Square root of 25. Yeah, good call, Andrew. Square root of 25 is 5. So guess what I'm going to do right here? I'm going to take the square root of 25. Told us, hey, that's as good as 1 plus 5 and 1 minus 5 in my equation on the right. Now guess what we have in our fraction is we have another equation. Remove this one right here, that one right there. Let's do numerator first. What's 1 plus 5? That's 6 over 4. Now what's 1 minus 5? 1 minus 5 is negative 4 over 4. And now all we have to do is do 2 division problems. 6 divided by 4. If you're a fraction person, it can be written as 3 halves or 1 1/2. If you're a decimal person, is 1.5. Guess what? We got one number, one answer. And what is negative 4 divided by 4? Well, that's anything divided by itself is 1, and negative divided by positive always results in a negative quotient. How many answers did I get? 1, 2. How many answers did I expect to have based on that highest exponent? As it loads, boom, 2. And it didn't involve any factoring at all, it just involved plugging things into this crazy looking formula and then using order of operations all the way down. So the formula is a cheat sheet that makes solving significantly easier. It only involves figure out where your A, your B, and your C are, plugging them in, and then using a calculator and PEMDAS to our advantage. So I'm going to keep this zoomed out here for about 15 to 30 seconds. Move into another example because this is one of those processes that really gets understood, I think, through repetition, kind of like factoring did, but this just now allows us to figure out where we're placing things. So I'll stop talking for about 15 more seconds. All right. Okay. We got a practice problem here, and then we're going to work on some of our assignment problems. Cool? So first things first, step number one on number 5. This is on the next page down, page 685. Again, we're in the text. It's not allowing me to zoom. There we go. Page 685 right there. We're doing problem number 5. A lot of fives on this one. Okay. I want to use this. I want to solve this quadratic equation. By the way, I can solve it a variety of ways, but the first thing first that I need to do, the very first thing I need to do is set one side equals 0. Anytime you're solving for a quadratic, that's always step 1. Now they're trying to make it difficult here in this process because at most of the other lessons, we haven't had to deal with that. We've already had that situation going on, like flashback, and I'll move it back to what there in one second, but flashback to lesson 17, that was not a problem because guess what? They gave us equations most of the time already equal to 0. Okay, we didn't have to deal with that back in 17. We were just learning basic factoring. They gave us equations that were already equal to 0. Now, we've moved past that. We're too smart for that now. We've leveled up. So first thing we got to do is we got to take this equation, set one side equal to 0. Does anyone have a recommendation as to potentially how I could do that? What do y'all think? Nice, Andrew. Andrew says let's set this side equal to 0. Okay. So he says if I want to set the right side equal to 0, I got to get rid of the positive 7x by subtracting 7x. And we know that if we do that on one side, we subtract 7x on the right side. Got to subtract 7x on the left side. And then he said also, if he wants to get rid of a positive 3, he's got to subtract 3. And if he does that on the right side, he's got to do that on the left side. So I've already started writing the new equation down here, just so I didn't stack 2 subtraction problems right beneath the 6x squared. But effectively, he subtracted 7x from 7x. Notice it happened here again on the left side. He subtracted 3 from 3, and then all he's left with now is 0 plus 0, because 7x minus 7x is 0, 3 minus 3 is 0, and 0 plus 0 has succeeded in goal number 1, set one side equal to 0. Awesome. Okay. Now that we've done that, I've sufficiently used all of my room for this problem. Probably going to need to move into I'm going to end up moving into number 6 in a second. Just block it out so it doesn't distract us. Now that we've done that, rule number 2 or step number 2 is figure out your A, B, and C. Cool. Anyone know what my A is in this case? 6. Great call, Andrew. What about my B? Nice. All right, we're getting it. Okay. The whole reason why we stacked this in descending order, we learned that about a month and a half ago, was for this exact moment right here, for this in factoring. A is the first number, boom. B is the next number, -7, which means our C has got to be our last number. And what's our last number? -3. Sweet. Make sure we follow those signs too, because that's negative and negative. So -7, -3, right? So last but not least, step number 3, plug A, B, and C. All right, and what the heck is this formula? Here we go. I'm gonna write it in green. The formula itself is going to be popping here. Remember, we're always solving for the value of x that makes y equal to 0. So the answers for x are going to be equal to the negative b value plus or minus the square root of b squared minus 4ac, all of which is over 2a. It is a formula. You can literally do a quadratic formula. You'll find it pop up to you immediately. Do not focus on memorizing right now. Focus on this next step, plugging it in there, okay? So step number 3, I'm going to continue right up here. Here we go. Here's my formula. X equals negative b plus or minus. I'm going to copy and paste it up here. I just wrote that formula down there to reiterate it, to repeat it. But guess what? Do I now have an a value? For sure. Anywhere that I have an a in this equation, in this formula, a and a, I'm going to make it into my a value of 6. So both of these a's, boom, boom, are the number that we know a is. 6. Okay, cool. We plug in a. Do I have a b value? No doubt. My b value is negative 7. So I'm going to take anywhere that there's a b in this formula, boom, boom, and make it 7. So that b is going to become a negative 7. And b squared will become negative 7. Squared, a little bit better because I'm kind of crunching it in here. Sweet. Last thing I need to figure out is plug in my c value, and my c value was negative 3. So now anywhere that I have a c in this formula, kind of got squished in here. My c value is just going to become that c value we know to be negative 3. Now, everyone, we have, notice we literally have the thing that we're looking for, x, isolated. That was our rule way back in September. Anything that you're looking for, anything that you're solving for, get it on one side of the equation by itself. Hey, we did that. X is already by itself. Now we just got to do this monstrous problem over here on the right, but that's totally doable. And here's how we're going to do so. Ready? One step at a time. Negative 7. What is negative 7? Ah, that's positive 7. Plus or minus. Here we go. I'm going to do negative 7 squared. What is negative 7 times negative 7? Well, negative 7 squared times negative 7 is 49. Sweet. Okay. Ready? Minus 4 times 6. 4 times 6 is 24. And now we have, think about it this way, what's 24 times negative 3? At a time. We'll go that into the next one. Here we go. We're here at this point. And last but not least, do 2 times 6. What's 2 times 6? 12. So we're getting closer to solving this down. And yeah, Andrew, you are right. 24 times 3 or negative 24 times 3 is actually going to give us 72. You're right, man. But we'll see that in our next step. Let me copy and paste this down here. Boom. Okay. Last thing we need to do is figure out what Andrew just told us, and that's, I'll use brown here. Negative 24 times negative 3 is 72. Okay, this is where we're at, y'all. We plugged in our B, our B, our A, and our C, and then we started working down with PEMDAS. We did negative 7, got positive 7. We did negative 7 squared, got positive 49. We did 4 times 6 and got 24, and we did 2 times 6 and got 12. Then at this step right here where I'm circling around, we did the product of negative 24 and negative 3 and got positive 72. Now all we got to do is figure out what the sum of 49 and 72 is. That number is 121. Sweet, which is awesome. Because what's the square root of 121? Does anyone know that? Notice we're still following PEMDAS, y'all. We did all that work first. Yeah, Francis. Yeah, Andrew, good call. The square root of 121 is 11. So now that monstrous problem has actually turned into a much easier problem. Move these things around. And this fraction says, all right, x is equal to, block this out, this is My writing's so big, it's kind of hard to fit in one little square. We're saying here that x is equal to 7 plus 11 over 12. At this point, x is equal to 7 plus 11 over 12, or x can equal to something else. And here's where we're going to get the variation, the two different formulas. 7 plus 11 in our numerator, or 7 in pink minus 11 over 12. Notice our denominator does not change. It's only the plus minus. All right, the last steps. 7 plus 11 is 18. Sweet. 18 divided by 12 is coincidentally the same number as the first answer. Cool. Or 7 minus 11, numerator minus numerator, 7 minus 11 is negative 4. Negative 4 divided by 12 is 0.3 repeating, or if you were to round it to the nearest tenth is 0.3. How many solutions do we have? Solution number 1, solution number 2, and it makes sense because exponent tells us we should have potentially 2 answers to this equation. Formula. Factoring this, really hard. And I can say that with expertise because I'm an algebra teacher. And I can say that with certainty because of the fact that your answers are decimals. So if you were factoring this, you would have to get basically decimal factors. And I don't think any of us want to be dealing with that. The quadratic formula is a cheat sheet. You set the equation equal to 0. You figure out your A, your B, your C. You plug it into this Mondo formula, and then comes the actual math. But you can use calculators. The one thing you got to do is make sure you use PEMDAS to your advantage. And Andrew, I just saw your answer. Great job, man. 1.5 or negative 1/3. Solid work. All right. A little long explanation, I know. But let's get down to one of our homework problems, and then we might cut it out a little bit early so I can answer any questions that y'all might have, okay? So let's see. First homework problem. We're now cruising on down to page 691. Nope, 692. We're going to do number 6. Sweet. Number 6 is awesome. You could actually solve this one by factoring, okay? So this is what we're going to do. We're going to solve it by using the quadratic formula, and then I'm going to verify it. Over here, I'm going to verify it. All right, and this is going to be our wrap up for today. Number 1, set equation equal to 0. Guess what? Sweet, we already have that done. So now step number 2, let's figure out what our A, our B, and our C are. And Zaid, I saw that X tactic. I know we'll get there. For sure, we'll get there with our X tactic. Don't you worry. I see you. Okay, what's our A value? Since it's already written in descending order, our A value is our number in front. What's the number? If you can't see it, it's got to be a 1. Okay, what's my B value? What's the second number you see? Like we read. Oh, it's a positive 2. So my B value is just going to be 2. And last but not least, what's my C value? The last number we see? Negative 8. Boom, boom, boom. Okay, here we go. Now we have our A, our B, and our C. We use our quadratic formula. X equals negative B. Plus or minus, again, don't focus on the memorization. I'm going to try to brainwash you into remembering this right now, but you always can use the formula to your advantage, just like we would on the test. Use 2. So B squared is 2 squared minus 4 times A. What's my A value? 1. Times C, which is going to be our C value of negative 8. All of which is over 2 times A, and this is my favorite situation when A is 1 because the multiplication is super convenient and easy. Okay. We plugged it into the quadratic formula, and now it's PEMDAS time. Let's get this party started. Well, we already know what negative 2 is. That actually took no calculation. So basically what I'm saying is don't worry about that. That is just literally minus 2 or negative 2. Let's do everything inside the square root first. Ready? Let's use a different color. What's 2 squared? Well, 2 squared is 2 times 2 or 4. What is 4 times 1? 4 times 1 is 4. And let's do 4 times negative 8 now. What is 4 times negative 8? Rapid fire multiplication, negative 32. Boom. All that multiplication times table stuff that we did back in 5th grade now starting to pay off. Cool. All of our stuff in our radical sign and our square sign almost done. But guess what? We're not fully done yet because we have slash and dash. Okay. What is 4 plus 32? Anyone know? Anyone know? What am I going to get inside my radical to finish off this problem? What would be the outcome of this thing here, highlighted in dark blue? 4 plus 32. Yeah, 36. Good call, Andrew. And that's awesome because I think we might know what the square root of 36 is. We'll see at least in a second after I shrink this down because I always run out of room. We said we would do the square root first. We'd do all the radicals first. It told us that the square root, after all of this, b squared minus 4 times a times c, b squared was 4. The product of these numbers here was negative 32. We added them up, got 36. Anna says she knows what the square root of 36 is, and that is 6. So now we have negative 2 plus or minus 6, because that was the square root of 36 all over. Now let's take care of business down here. 2 times 1 is just 2. Sweet. Now we have two equations. Ready? X is equal to negative 2 plus 6 over 2. Wait, what? Ah, yeah, it's the plus or minus. So negative 2 plus 6 over 2. Or x is equal to still negative 2, but guess what? Now the differentiation comes in the minus 6. Negative 2 minus 6 over 2. And again, where I got that minus sign from was right up here. 2 equations because it's both plus and minus. Negative 2 plus 6, negative 2 minus 6. Denominators the same. It looks like Andrew's given us an answer because he says, all right, negative 2 plus 6 is 4. 4 divided by 2 is 2. Sweet. Or negative 2 minus 6 is negative 8. Negative 8 divided by 2 is negative 4. 2 solutions. Okay, real quick verification of the process by factoring. All right, here's how we would factor this thing. Our equation was x squared plus 2x minus 8 equals 0. We're going to verify that answers are correct by factoring. We're going to do so right now. Let's see if we can do this. I believe. Well, yes. We have no GCFs, so I'm going to zoom in on the factor process. All right. If we have no GCFs, we go to what Zaid was doing earlier, the X tactic, and we do first number times last number. First number was, by the way, if you know the quadratic formula, you literally already know what the first number and the last number are. First number was 1. 1, last number is negative 8. 1 times negative 8, boom, negative 8. What was our middle number, our B value? Oh, 2. So now we got to find the factors of, got to find those factors of negative 8 that add up to 2. To add up to 2? Well, none other than positive 4 times negative 2 gives us negative 8, and positive 4 plus negative 2 do add up to positive 2. So now we're rolling. We're like, here. We combine these two things. We say, all right, x squared minus 8 equals 0. Why? So I could expand this 3-term things into 4 terms. And those expansion are going to come from that positive 4 and that negative 2. And why did I expand those into 4 things? So I can make 2 groups of 2. I can't really do the well, but 2 groups of 2. Ready? Group 1, boom, boom. Group 2, awesome. What can I take out of this group? Well, they both have an x. So my GCF x gets pulled out. And on the inside, I'm left with x plus 4. What can I take out of both terms in the second group? Both negative 2x and negative 8 are equal to GCF. And when I divide those by negative 2, what do y'all notice about my parentheses? Finish off our beloved factoring tactic by combining my red things, my GCFs, x and negative 2, aka x minus 2, times that common parenthesis x plus 4. And then we use the zero product property. Final step, we set both factors equal to 0. Now we solve. I feel it. I feel the wave of success coming on us. Boom. X is equal to 2. How do we get rid of a plus 4? We subtract 4. X now by itself is equal to negative 4. Wait. Boom. Verified with factoring. Okay. Not everything's factorable, but everything that is a quadratic, a power of 2, can be solved with the quadratic formula. It just so happened that this one was factorable, so I wanted to practice that process. But I guarantee you this process right here works 100% of the time, every time, as long as we do the math correct, the PEMDAS correct. Anytime you have a power of 2, the quadratic formula works for you. All right, y'all. That was a lot of math being like thrown at you rapid fire. So hopefully, if you're watching this and it's recorded, you're pausing it and looking at the math. If you need, please go back and watch this recorded video again. I'm going to post this after I have some lunch. And last thing I want to say before taking off is please fill out that Google form. I'm going to be sending out the optional project to those who requested it via email today. So based off these answers that I got on the Google form, which it looks like 3 more of you have already done so since we started this lesson, sweet. If the optional project can help you and you requested it, keep an eye on your email because you'll be getting it probably within the next hour or 2, okay? And then on that note, if you have any questions, feel free to unmute yourself, feel free to type in the chat box or email me. If not, have a great rest of your day, everyone. Have a fantastic weekend. No mandatory classes next week, but always feel free to reach out to me, okay? I appreciate every single one of you so much. It means a lot to me, and it just shows your character. So on that note, bye, y'all.